Today on Capechi's Corner, we're going to look at tangents. When we're looking at our tangents today, we're going to start with a few theorems. The first theorem says if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So if I know that it's tangent, if I tell you that this line is tangent, then you know when it touches the circle that we're going to form a 90-degree angle there with the radius. Now the second theorem is the converse of that. If I tell you that the line of a circle is perpendicular to a radius at its outer point, then I know that the line is tangent to the circle. We also know in talking about tangents that if we have tangents to a circle from the same point, so in this case we're coming from point A, that when these tangents hit the circle, they're forming segments that are congruent. So for instance, if I take A and go to B, and A that go to C, then I'm going to form congruent segments. Now if I have a line that is tangent to each of two coplanar circles, we call that a common tangent. So we're talking about the lines right now. In this first example, I can say that we have an internal tangent. And what that means is that the line is going in between or inside. I like to look at internal as saying inside the circles. If I'm looking at an external tangent, then I know that's going to be on the outside. So if you notice, this line that's tangent, does not go in between the circle. It basically stays on the outside. In that last example, we were talking about the lines, the tangent lines. In this case, we're actually talking about tangent circles. So this can be confusing. So again, it might be a good idea to view these or take notes on these so you make sure you're okay. Tangent circles are coplanar circles, meaning they're in the same plane. They're tangent to the same line at the same point. So in our first example, the circles are externally tangent. If I were to bring a line right down the center, both circles are tangent to the same line, so we say that these circles are externally tangent. If we look at our next example, internally tangent, one circle is inside the other. So again, they're both tangent to the same line right there. But since one circle is inside the other, we talk about that as being internally tangent. Let's take a look at some of the vocabulary words we talked about today. So we have a very involved diagram up here. The first question says we're looking for a tangent to circle P, but not to circle O. So we're looking for something that touches on the outside of P, but not the outside of O, and that would be this line right here, so OB. Now remember, tangent is a line, so I need that line segment on top. Number 2 says we're looking for a common external tangent to circle O and circle P. So in this case, it's going to be this line CD, and we say that that is an external tangent line because it's tangent to both circle O and circle P, but it does not go in between them. It stays on the outside. Now in our last question it says we're looking for a common internal tangent to circle O and circle P. So we're looking for a line that goes in between the circles and touches both circles on the outside. So it's going to be that line right here. So it touches circle O at point A, and it touches circle P at point E. So we're going to say that internal tangent is going to be line AE.